Welcome. Let's look at these two formulas, the distance formula, and this one is a memorize. Must memorize it. It actually comes from something that we're used to, which is the Pythagorean theorem. And that's because the A is actually based on the difference of two X's and the B on the difference of the two Y's. And that's what makes the distance formula. So let's actually do it in two ways here so you can see how this comes about. So on the first one here, we have two sides, 6 and 8, right triangle. So we'll call this one A, so we get 6 squared, and this one B, so we get 8 squared, and that's 36, and 64 adds to 100, and the square root is plus or minus 10, but you never use the negative for a distance, so that means it would be 10 units. Easy to do if you have the actual amount. If you don't have the amount, but you have the points, well, let's actually put the points on and let's do the same thing, but let's do it based on these points. So this point that's here, the x value is 9 and the y value is 2. And this point that's over here, the x value is 1 and the y value is 8. So now we're going to take the two x's. Okay, and actually, let's actually call these. This will be the first of these is x1, y1, because it's our first point, even though I wrote it second. I'll call this one x2 and y2 because this is our second point. So here I'm going to do x2 minus x1. So that's 9 minus 1, because here are the two x's. And then I'm going to do the two y's, so it's going to be 2 minus 8. The order matters here. Make sure that you keep consistent so that this is x sub 2 comes first, y sub 2 comes first. Now, 9 minus 1 is 8, and that'll be squared, and that comes to 64. 2 minus 8 is negative 6, but when you square it, you get a positive 36. You get 100, and then the square root of that is plus or minus 10, but we're not using the minus. So we still get 10 units for the hypotenuse in its length. 10 units here. And this one's 10 also. So this method is based upon using the points. And it's the same concept, same idea. So let's find the distance between these 2 points using the distance formula. Okay, so the distance is equal to the square root of x sub 2 minus x sub 1, and then you're going to square it, and you're going to add y sub 2 minus y sub 1 squared. Notice here that you're adding the two things, but inside it, it's negative. That might help you to not get them mixed up. Think about the differences so that you can get these correct when you do them. So I'm going to call this one x1, y1, x2, y2. So I'm going to put the x's in there first. X sub 2 is 5. Take away, and x sub 1 is a negative 4. And then we'll square that. Notice what I did here, because it's two minuses, I put the 4 in the parentheses to make sure I could see that those were two separate minuses. So in a moment, we'll make a plus. Right? And then we're going to add to it, y sub 2 is minus 1, minus the negative 6, and we'll square that. So in the next step, 5, that's going to be plus 4. Okay, so it's going to be, in fact, I'll write it as 5 plus 4 squared, plus negative 1 plus 6 squared. I'll have to go to that level of detail, but I don't really mind doing it. So that's going to give me 9 squared. 6 take away 1 is 5. That'll be 5 squared. And that's the square root of 81 plus 25, which is the square root of 106. And that's approximately 10.3 if I go to one decimal place, like 10.295 or something. Now, notice something in the question. Give an exact answer and an approximate answer rounded to the hundredths place. So back down here, I need to come down and see that that was supposed to be 10.295. 5 rounds the 9 up to 0 and adds 1, 3, so it actually is 10.30. And we'll put the 0 to show that we're going to the hundredths place, which is the second decimal. And this one is the exact answer because there's no rounding involved in it. And so the one with the square root would be exact unless it was a perfect square. So those are our two answers for this one, an exact and approximate. Now, looking at the midpoint formula, this is where we're simply finding the place in between. So if I have a 1 here, A, and B, we are looking for the midpoint here, M for the midpoint. So if this is 10 and this is 30, well, you can realize, oh yeah, this is going to be 20 because that's exactly in between 10 and 30. But one way to do it is to add the two ends and divide by 2. And so this method is what you're going to use because sometimes the numbers are not as clean as just 10 and 30, especially if they have decimals or whatever. Okay, so this formula involves adding up the two x's and then dividing by 2. And over here, adding up the two y's and dividing by 2. Really a pretty simple formula if you think about that. Well, let's do that here with this one. Let's find the midpoint between these two. Okay, so for the x's, I'm going to add the two x's, -4 plus 5. And it doesn't matter now which one comes first because we're adding them. And I'm going to divide by 2. And I'm going to take the two y's and add them. But I have to be careful of that negative. So that's equal to 5 minus 1 is 1/2. And here we have -6 minus 1. So that's -7/2. So that's an acceptable answer. Or you can put it in parentheses, in decimals, as long as you don't have to round it. Okay, so it's not acceptable if it was like 1/3 to do 0.33 most of the time. Depends on the problem sometimes, but usually if you get that, then leave it as a fraction so it's more exact. So both of these would be acceptable in this case because when you make them a decimal, there's no rounding. It's 0.5s. Okay. Now here's a different way to use the midpoint formula. This one shows this type of situation. You have one endpoint, and then that's one endpoint, and then you have a midpoint, endpoint and midpoint. But you need the other endpoint. We need to know what that one is. So what we need to do in this case is use this information, what the midpoint is. Here's how we're going to do it. I'm going to say that the x value for this one, we need an x and a y. That x value, well, actually, when we did going up here, this one here, that's the midpoint. The x midpoint is equal to this. The y of the midpoint is equal to that. So I'm going to say that the x of the midpoint, go write that a little better. X of the midpoint is equal to 1x plus the other x, and it actually doesn't matter if it's 1 or 2. Just put 1 here because it's just adding. Of one of them plus the other, divide by 2. And the y of the midpoint is adding the two y's together and getting 2. So here, we know the midpoint x, so that's 2. And we know the x of one of the endpoints. So that's -1/2. Okay, -1/2 plus the one we don't know. All right, and we divide by 2. So let's work with that in a moment, but let's come over to the y's here, and I'll do that one. For the y's, we have that's 4. The midpoint y is 4. And that's equal to the y of one of them plus the y of the other divided by 2. So what we have here are two little equations. So here on this first one, I'm going to multiply both sides by 2, because that gives me 4 equals -1/2 plus x squared. I'll add 1/2 to both sides. That makes that 0. So I get 4.5 or 4.5 is equal to x sub 2. over here, that means that this x is 4.5. Now let's do the other one. I'm going to multiply both sides here by the 2. I go, that gives me 8 equals 2 plus y sub 2. Subtract 2. 6 equals y sub 2. So that means that's 6. So our actual answer for this is 4.5. I want that point to show clearly. 4.5 and 6. Now, I'm going to yellow that in. I'm certain that those are correct. Let's actually verify something with this. Okay. All right. If I were to do a little graph here, and I plotted these points, 1, 2, 1, 2, 3, 4. The midpoint is here. The first endpoint is at -1/2 and +2, which is about here. That means that this is one endpoint, this is the midpoint. That means that this distance, you have to go further. And so this would be, we're hoping about 4.5 and about 6. Well, that's pretty reasonable. 1, 2, 3, 4, 5, 6. That's pretty reasonable for the y. And over here, 1, 2, 3, 4, probably about 4.5. So it's in that general area. So that means this is almost certainly a good one, because when I do a little graph there, it appears that it makes sense. That 4.5 and 6 does make sense, that it would be going past the midpoint, going to another point like that. Okay. Now, there are some practice ones here. Why don't you do this one yourself, pause, do this one, come back, and then I'll show doing it here. Go ahead. Okay, welcome back. We have that the distance is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So the distance is equal to the square root. Again, I'm going to call this my first pair and my second. So that's -3 minus 2 squared plus 0 minus 4 squared. Okay, so we have -5 squared plus -4 squared, which is equal to -5 to the -5 is 25, and here we have 16, so that's the square root of 41. Okay. And the square root of 41 is approximately 6.4. Now I took up a lot of space there, and I didn't actually do the midpoint one, so let's do the midpoint. So for the midpoint, for the x, I'm going to add the two x's, 2 plus a -3 over 2. And then the two y's, 4 plus 0 over 2. So here I have -1/2, and 4 over 2 is 2. Okay, or -0.5 and 2. So either of those would be acceptable. Now let's go down to the next one. Find the distance of and the midpoint of these two, and this time there's a couple more negatives to deal with. So go ahead and do this one yourself, and then come back to it when you're done. You can pause the video and come back. Okay, welcome back then. So I'm going to first do the distance formula here. I'll try to keep on separate sides now. So this will be x2 minus x1 squared plus y2 minus y1 squared. Now, I know this, so on one hand, maybe I don't need to write that every time. But by writing it, I keep myself pretty safe with this, so that I get my two x's right. So it's -2 minus the -6 squared, plus now the y's, 1 minus 3 squared. It helps me keep track of things, so I don't really mind rewriting it. In fact, I think it's a good thing for me to do. Oh, I forgot to put this in parentheses. So that's -2 plus 6, which means it's 4 squared. And -3 minus 1 is -2 squared. So the distance is 16 plus 4. And the distance is square root of 20. which is approximately 4.5. Good. So we have now the distance for it. Now let's look at the midpoint. The midpoint of the two x's, -6 plus -2 divided by 2. And the two y's, 3 plus 1 divided by 2. So that's -6 minus 2, which makes it -8 over 2. 3 plus 1 is 4 over 2. So that looks like -4 and 2. Okay. And this sometimes is worth checking. If I go to -6 and 3, it was somewhere maybe about here. And -2 and 1 is about here. So -4 and 2 would maybe be about here, which makes sense for the midpoint. Okay. Now, one last problem, and this time is where we know the midpoint, but not one of the ends. Okay, so on this one, we want to find k when we know what I is and we know what j is. -1, 4, and -3, -2. This is like one example I did a moment ago. All right, go ahead and do this one yourself, and pause and come back when you get it finished, and I'll go through it. Okay, welcome back. So I want the midpoint, and I remember that the x of the midpoint is equal to one of the x's plus the other x over 2. And so I'm going to put in that the x of the midpoint is the -3, and that's equal to the x of one of them plus the other x we don't know. This one over here is x sub 2, y sub 2. So I multiply both sides by 2 and get -6 equals -1 plus x sub 2. Add the 1, and I get -5 equals x sub 2. So this should be a -5. We're going from -3 to -1 to -3 to -5. That looks right. That makes sense. Now let's do the other one. The x of the y of the midpoint is equal to y1 plus y2. Sub 2 over 2. So in this case, that means that this is the y. So that's -2 equals this y, 4, plus the other y that we don't know, and we'll find out now. Multiply both sides by 2, and we get -4 equals 4 plus y sub 2. Subtract 4 from both sides, and we get that y sub 2 is a -8. So this should be a -8 here. So that means our answer is -5 and -8. And graph the points and see if it makes sense. This would be the other end, and actually I can assure you right now that it is. All right. And now that I've done that, I think I'll go over these as well. So those are some good examples of using the distance formula, the midpoint formula, and the midpoint formula one's got a weird little thingy in there, problem. So here now you, hopefully this helps you with doing these. Make sure you remember the two formulas because those are ones to memorize that aren't given, but you need to memorize those formulas. But they're not too hard if you practice them and study them. Hopefully this helps. Thank you for watching and listening.